Hi everyone, welcome back. Now we are going to see about the construction and working of DC generator. So just you can think and say your answer. Why do we need motor? What action motor to do? How can I create the motor or develop or manufacture the motor? Why motor rotate in a circular motion? So just you can think upon and put your answer in the comment section. So normally the motors has two types. One is nothing but AC motor, another one is nothing but DC motor. So the motor characteristics is very much important for the important, and because the fast reaction, better speed control, simple construction, low noise, like that, etc. So in the motor construction, so this is a schematic diagram. This is an schematic diagram. So this is nothing but yoke, or it may be called as magnetic frame, and this is nothing. These are the poles, and these are the field winding, and this is nothing but armature, armored slot, brushes, bearing, and etc. are available. So this is an just we can keep only and two poles. One is nothing but north pole, and south pole is nothing but a stator, and this is nothing but a rotating part armature, and this is nothing but a winding. It consists of, so like that. Okay. So the motoring action. So the motor of principle. So if a current carrying conductor is placed in a magnetic field, then the conductor it experiences a force in the direction mutually perpendicular to both the direction of field and the current carrying conductor. It is similar to, it is an exactly what they are coming to say. It is an Faraday's law of Faraday's it is a Faraday's law. So whenever the current carrying conductor is placed in a magnetic field, there is a tendency, so it cuts the fluxes and induces the EMF. Okay, so that is the motoring action. So here, according to the construction, it has a stator, the outer frame. The outer frame is nothing but a stator, and this is nothing but a stator frame. So in between these are the poles. And here these are the stator core. These are the stator core. So in this stator core we are providing the winding. The winding is called stator winding, or it may be called as an field winding. So, okay. Normally the stator is made up of silicon steel and the winding is made up of copper. Sometimes aluminium, but aluminium is it is an worst case because it is an poor conductivity okay. The next, so here when a DC current is passed through this field winding, the field winding, it creates a static magnetic field. It creates a static magnetic field. So there are two types of folds in a machine. One is a main field and another one is interpole. So this is the main field winding. It will be large in size, and the interpoles are in small size. So the interpoles, which is to avoid the escaping of fluxes from the commutation process. Okay. And these are the connections. So just we are linking the field winding. So the first field winding, which is interconnected with the second, and again it will be connected like this. Okay. So this is the connection of field winding for the continuous process. Okay. And this is a rotor. So this is nothing but a rotor bar. So it is in cylindrical shape. This is nothing but a rotor slot. That is nothing but an armature slot. So in this armature slot, they are providing the winding. This winding is nothing but an armature winding. So in this particular slot, we are providing the armature winding. So the armature winding will be inserted. So here it will be inserted here, shaft. So in the shaft, here there will be a commutator. There will be a commutator. The commutator, which is used to convert the DC to AC as well as AC to DC according to the application. So this is for motor. So motor means it converts the AC to DC. The generated electricity is AC. The AC is converted into DC. Okay, am I right? No, it is not right. It's not right. Okay, so because this is for AC, generator. Sorry, this is for DC generator. For motor, okay, we are giving the DC supply. The DC supply is converted into AC, okay, for the machine operation. And this is because of bearing at both side, okay, now both side of the shaft for the rotor is capable of rotating at freely. It is free to rotate the shaft. And the principle is it's behind left hand rule. Its principle is left hand rule. And the working. So whenever the current carrying conductor is placed in a magnetic field, so there will be a tendency the armature gets rotated. While rotating the armature, it cuts the fluxes, and it will be inducing the EMF. That induced EMF is nothing but a back EMF. So these are the construction of the rotor. So how with the help of a small north and south pole, how the EMF is induced, how the rotor gets movable in this particular segment with respect to the DC sources. So this is an assessment. Which part of the motor confirm that it is a DC motor? So the question, now we have to identify DC motor compared to AC motor. So okay, so put your answer in the comment section. Thank you. And these are the few references.